Welcome to Fast Philosophy. This video is part of our Translating Into Propositional Logic series and explains the grammar and punctuation of sequence. In natural language we talk about arguments, which are made up of premises and a conclusion. But in formal logic, instead of arguments, we talk about sequence, and instead of premises and a conclusion, we talk about formulas. Now that we understand the grammar and the punctuation of well-formed formulas, we must understand the grammar and punctuation rules of sequence. The vocabulary of sequence is similar to the vocabulary of formulas, but there are some additional grammar and punctuation rules for sequence. Here is an example of a sequent to help us visualize these grammar and punctuation rules. The grammar of sequence is that they are written horizontally, left to right, with premises to the left of the conclusion. The punctuation of sequence is that commas separate each premise, and that a symbol called the turnstile separates all premises from the conclusion. Let's translate a standard form argument into a formal sequence in propositional logic. Why not? Premise 1. Socrates likes pineapple. Premise 2. If Socrates likes pineapple, then Socrates likes quince. Conclusion: Socrates likes quince. The vocabulary of our logical language consists in atomic formulas and logical operators, represented using sentence letters and logical symbols. We need a key to show which sentence letter stands for which natural language proposition. Let P equal Socrates likes pineapple and Q equal Socrates likes quince. Our first premise is P. Our second premise is if P then Q, so we need to use a logical operator, the horseshoe. Using the horseshoe requires that we employ brackets as punctuation. Our first and second premises are separated using a comma according to the punctuation rules for sequence. Lastly, our conclusion is Q. Now we'll separate all premises from the conclusion using a turnstile according to the punctuation rules of sequence. The turnstile effectively replaces the inference bar that we used in standard form to stand for therefore, but in formal logic it's more properly understood as standing for is a logical consequence of. Now that we understand the vocabulary, the grammar and the punctuation rules for well-formed formulas and sequence, we can begin translating from natural language into formal logic.